Hello all, let's start section 2.2. Section 2.3, sorry, 2.3 is about inequalities. I want to discuss inequalities from beginning to you, give you an idea what is inequality, what are the properties of inequalities, how to write the solution set, how to graph it. We call it graph it, but actually how to show your answer on the number line, and how to solve an linear inequality, then later absolute inequality, compound inequalities, and other types of inequalities. But let's start from the beginning and translate what does it mean inequality. Look, I put few sentences on the left side of my screen for you. For example, when I sing in English, I have $5. Of course, in mathematics, we create our own language of mathematics. In English, I can say I have $5. In mathematics, how to show that one in an easy way? If I name my money X, my X is $5. Correct? X is $5. I have $5. But what if I have, for example, $4? If I have $3? If I have $6? The other four sentences that you see, we call them inequalities. And I will translate those for you with the sign. Actually, I introduced the sign here for you. The second sentence that you see here, it means I have in English, I have less than $5. Again, if I name my money X, less than $5, I will use this sign and I will write a 5 on the right side. Let me introduce this sign. This sign is the inequality sign. On the mouth, the sign has a mouth and also has a vertex. This point we call it vertex, right? When you write a number on a vertex side, it means that number is small. And when you write a number on the other side of this sign, which we call it a mouth, correct? And this side, this number is actually big. I have less than $5. It means I have maybe $4.5, $4, $3, $1, but anyway, definitely my money is less than 5. I have more than $5. Again, if I name my money X, more than $5, I will write this way. X greater, I will read greater. Here, I'll read less than. Here, I will read greater than. Correct? I have greater than $5. I have more than $5. In every single case, you see I am putting my variable on the left side. I will not write this way. I have more than $5. It's not wrong, to be honest, it's not wrong. But what we do, we usually try to keep our variable on the left, and always we read from left to right, not from right to left. If you write this way, then you have to read your inequality from right to left. Or in a simple sentence, when you read an inequality, always read your inequality from variable side, not from number side. Do not read 5 less than x. Read x greater than 5. Correct? I have 5 or more than $5. If my money is x, I have more than $5 or $5. Greater equal. We use this sign. I have 5 or less than $5, then X less than equal 5. In general, what are the signs? You have greater than, less than, greater, equal, less than, equal. We call these signs inequalities. Correct? Now, how to show them on a number line? For sentence number, let me erase a little bit this side to show it here for you. For sentence number 2, I have less than $5. If you draw your number line, correct? This is your number line. Here is your 0. Here, of course, on the right side, you have positive numbers. On the left side, you have negative numbers. I'm not going to explain this for you. You are way above this explanation. Your knowledge is way above. You already know this. Here, of course, you have positive infinity. Here you have, of course, negative infinity. 1, 2, 3, 4, 5. 5. I have less than $5. In old books, you mark your 5, correct, with the open circle, and less than 5. Which side is less than 5? Shade that one. You see, I will draw an arrow. Less than 5 is all the way going to here, correct? This is how you show your inequality. X is less than 5. You use an open circle. Or in the new books, including your book, instead of open circle, we use parentheses. You open a parenthesis to the left and you draw your line or shade the left side. Correct? Sentence number 3. I have more than $5. If I draw my number line again, infinity, negative infinity, here for example 0, here for example 5, more than $5. I will draw a parenthesis in 5, and more than 5 is of course the right side. Up to where? Up to infinity. Correct? Sentence number 4, if I translate it on the number line, again, negative infinity, positive infinity, here somewhere 0. I have 5 or more than $5. If I mark this point as a 5, you can draw a closed circle. Maybe you saw it before when you were in high school or school, correct? In new books, for closed circle, we use a bracket, correct? Open left or right. Bracket means closed circle, or you can draw here a closed circle. What is the meaning of bracket and why parentheses? Or what is the meaning of open circle and closed circle? After I finish with sentence number 5, I will explain those for you. Bracket or closed circle actually means included. Open circle and parentheses means not included. Here, this one means not included. This one means included. Correct? I have 5 or more than $5. It means starting from 5 to where? To infinity. Let's translate the last sentence, then we can talk more about these signs. Last sentence. Here positive, here for example 0, here negative infinity. I have 5, mark your 5, or less than $5. It means use a bracket or a closed circle opening to the left. correct? Now, few things about these signs. Let me make a short note for you. For less than and greater than, use open circle, or in your book, I'll recommend you to use parentheses instead of circle, correct? For less than equal, greater equal, use always a closed circle or a bracket. For negative infinity and infinity, we use always parentheses. Why? Because we cannot include infinity in our answer. Infinity is not a number. Infinity is just a symbol. We don't know the value of infinity. That's why we always use parentheses for infinity. Correct? Let's do some more examples. Okay, that was how to show your answer in a number line, correct? Now, how to show your answer in a function notation form. We call it notation form, correct? Some professors, they ask both. When you solve an inequality, they tell you, including me maybe, draw the number line, show your answer, and after that, write your answer in notation form. How you can write your answer in notation form? It's really easy. It's nothing difficult about if you just know this. If you just focus on this part of lecture. Sometimes I'm getting confused why some parts of mathematics gets difficult for students. I'm not blaming students. Sometimes I'm thinking it's our mistake. Maybe we don't explain very well. Maybe we don't explain, or maybe our students, they don't focus. Maybe blame on the students, right? They don't focus. But if you focus on these, writing an answer is not difficult, correct? Look at this. How easy is that? For 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 sentence number two. For sentence number two, I have less than $5. Look at this, less than $5. When you write your answer, you have to use these two numbers to write your answer, correct? Starting from negative, you see the red line is starting from negative infinity to 5. Then for negative infinity, what do you use? A parenthesis? Yes. Open a parenthesis, put your negative infinity, then comma, to where? To 5. And what you used in the graph for 5? Open circle or parentheses, copy that here. We call this one function notation form. Correct? For sentence number 3, I have more than $5. Start from lower number with the smallest number always. Look here, in negative infinity is small. I start from negative infinity. Then I went up to 5. Now in sentence number 3, my small number is 5. What I used in my graph for 5? Look at there, a parenthesis. I'll open a parenthesis, put 5 here, comma, to where? To infinity. And which should I use, bracket or parentheses for infinity? Look at this table. For infinity, always parentheses. Correct? Sentence number 4. I have 5 or more than $5. Look, for 5, what I used for 5? A bracket. Then open a bracket, 5, comma, infinity, and for infinity parentheses. For sentence number 5, I have 5 or less than $5. Okay, from where you should start? Should you start with a 5 or should you start from negative infinity, right? Of course, from negative infinity, but because that's your smallest number. We follow the number line, right? Then parentheses, negative infinity, comma, 5, and for 5, bracket. Hope you understand how to write your answer in number line and also in notation form. Now, let me put a sentence here for you. When you are dealing with equations, remember this, make a note. When we are dealing or when we are solving an equation, we have exact answers. For example, if I solve this linear equation, x plus 1 equal 6, if I solve it, I subtract 1 from both sides, correct? Then x equals 5. Exactly, I'll get one answer. If you solve a quadratic equation, you may end up with two answers. Degree 3, 3 answer. Degree 4, 4 answer. But still, you have one exact or two or exact answers. But when you are solving an inequality, that soon I will explain to you how, but right now I'll show it to you. Same example. For example, if I have x plus 5 greater than 6, your answer becomes a set of solution, not only one. It will be a set. Look, if I subtract 1 the same way that I did for my equation, these two cancels out, then x greater than 5. You already saw the number line. If I draw this greater than 5, for example, here is 5, greater than 5, how many solutions I have from 5 to infinity? It's a set. It's a set of solution, not only 1, 2, or 3. It's a set. How many numbers we have there? A lot, right? That's why when you solve inequalities, even you solve it correctly and you write your answer like this for me, x greater than 5. Oh, the 5 is the answer for this inequality? No. Not only 5, a set of numbers. What does it mean a solution? A solution means it should satisfy the given equation or inequality. Look, I have x plus 1 greater than 6, correct? Any number greater than 5 should satisfy this inequality. For example, if I use 6, 6 plus 1 is greater than 6. If I use 7, 7 plus 1 is greater than 6. But if I use 4, you see on this side, which 4 is here, is 4 plus 1 is greater than 6? No. Correct? These are really important points that I'm raising with you during this lecture. Your book just jumped to the few properties of inequality, and after that, because they think you already know this, the author of this book, they're thinking that you finished your elementary algebra, which is this is the topic from elementary algebra. Also, this topic comes in intermediate algebra. Also, this topic is in college algebra, and now you are in pre-calculus. They don't want to write the book with all details, but I'm trying to give you some details here for some of you that you may forgot this topic or maybe it's new for you, correct? Now, rules or properties. Equations, and here, let's say inequalities. I'll do both for you to remind you. There were four famous properties of the equations. Actually, those are, we call them properties or rules, but actually that's the method that you are solving an inequality, correct? What was the first one? Number one, the addition rule or the addition property. If you have an equation, for example, A equal B, if you want to add a number on the left side, for example, a number C, you have to add the same amount on the right side to keep the balance, right? For example, numeric example, 2 is equal to 2. If I want to add 3 on the left side, then I have to keep the balance. I have to add the same amount also on the right side, correct? Number 2 was the subtraction property or rule. Before going to 2, same property applies to inequality also. If I have a number A greater than B or a number A less than B, any of those 4 signs, correct? Or if I have A greater equal B or A less than equal B, I'll just use one of them, maybe this one, A greater than B. If I want to add a number on the right side, I have to add the same number on the right side to have the same condition, correct? For example, 3 is greater than 2. If I want to add to the right side 2, I have to add to the left side also 2 to keep the balance. You see, 3 plus 2 gives you 5 and 2 plus 2 gives you 4. Still 5 is greater than 4, correct? The second rule was subtraction, correct? If you have A equal B, if you subtract a number from the left, you have to subtract the same amount from the right. It applies also to inequality. Rule number 2. If you have A greater than B, or A less than B, or A greater equal B, or less than equal B, if you subtract a number from the left, you have to subtract the same amount from the right too. Number 3 was the product, correct? If you have A equal B, if you multiply the right side with a number, you have to multiply the left side with the same number also, correct? It applies to inequality, but I will add something. If you multiply a positive number, here, even if you multiply a negative number, it doesn't matter for the equations. But when you are dealing with inequalities, be careful. Focus here, what I'm explaining. Number 1, 3a. Let's name it 3a. If I have a greater than b, if I multiply both sides of my inequality with the positive number, I'll show it this way. C is greater than 0. It means C is a positive number. Positive number. If you multiply an equality with a positive number, you should multiply the right side with the same. But what happens if you multiply an inequality with a negative number? Look, I'll name it 3b, rule 3b. If I have a greater than b, if I multiply a with the negative c, based on the rule, I have to multiply b also with the negative c. Here, I will tell you, flip the sign. Why? Look at here. For example, 3 is greater than 2. If I multiply 3 with negative 1, and if I multiply 2 with negative 1, if I keep my sign like this, look what's happening. 3 times negative 1 gives you negative 3, and 2 times negative 1 gives you negative 2. Which number is greater if I keep my sign like this? Is negative 3 is greater than 2? Wrong. Then what it says, when you multiply an inequality with a negative number, multiply both sides with the same number, but flip the sign like this. With equations, we don't have this rule. It doesn't matter if you multiply both sides of an equation with a negative number or positive number, still it will be the same. But with inequalities, be careful with this. Correct? Rule number 4, or let's call it 4a. If you have an inequality a greater than b or less than b or greater equal or less than equal, if you divide one side with a positive c, and you divide the other side with positive c, you are okay. Here c is greater than 0. It means c is a positive number. But in 4b, if you divide one side with a negative number and you divide the other side with negative number, that means c is less than 0 here, correct? It's a negative number. You have to flip the sign. And you already saw the reason why. Correct? These are the 4 famous property of the inequalities. We name them property. That's actually the way that you solve an inequality. Using these 4 steps, you can solve any equation, correct? This is what we use to solve an inequality. Now, I will start with the first example and I'll show it for you. How you solve an inequality, how to show on the number line, and how to write your answer in notation form, correct? Let's take this example from your book, example number 1. Oh, red color, no, let me use black. For example, if they ask you to solve 2x minus 3 less than 8, you always start the same way that you start with your equations. First, I will add 3. You see, adding a number to both sides. I'll add a number. I used one of my properties, correct? I add a number to both sides. Then 2x is less than 11, correct? And now, next step, I have to divide both sides of my inequality with 2, correct? These 2 cancels out, then x less than 11 over 2 is my answer. I'm not satisfied with this answer. I have to show it on the number line. This is infinity. This is negative infinity. I don't care what is 11 of the exact value of 11 over 2, which is 5.5, right? 5.5. Just mark 1 point on your number line as 11 over 2. Now, x less than equal. For less than equal, remember I told you use a bracket or closed circle. Which side you have to open it? Of course, to the left, because the left side is smaller. How to shade? This is the shading area. You can shade it or you can just draw a arrow here. Now, how to write your final answer in notation form? Parentheses, negative infinity, comma, 11 over 2. Actually, you see, I'm just copying this bracket. I'm copying my number line. Example number 2. That example was not a good one in your book. The first example with a fraction. 5x plus 8 less than equal 7 plus 7x. What I do, I'll bring the x's to one side, number on the other side, right? It means I'll subtract 8 from both sides and I'll subtract 7x from both sides. It doesn't matter. In school, I know they explain for you, oh, move the 5x to other side. It's much easier. It doesn't matter. It doesn't matter which side you move it. Just focus on the signs that you will end up with the same answer, correct? I did two steps together. 8 cancels out. 5x minus 7x gives you negative 2x. Less than equal. These two cancels out. 7 minus 8 gives you negative 1. Be careful with the sign. You are in pre-calculus class. Now divide both sides by negative 2. If you are a good student, if you are a good listener, I already explained to you one of the rules. When you divide both sides of an equality with a negative number, you have to flip the sign. You had less than equal, it becomes greater equal than negative 1 over negative 2 gives you 1/2. Final answer, number line, here is 1/2, greater equal 1/2, bracket, moving to the right to where? To infinity. Write your answer as a notation, bracket, 1/2, comma, infinity. Correct? These are the simple types of inequalities. These are very simple types of inequalities. We call them linear. They're really easy linear inequalities, correct? Let me do one from maybe your kind of type of homework, because you will deal with your homework and I don't want to see that you are struggling in your homework. Let me copy problem number, I'll do it as an example. This is actually problem number 2.3, correct? Because you have similar problem as a problem number 5 or number 7 is the same. Let's solve this problem for you, correct? X minus 1 over 4 minus x 2x plus 3 over 5 less than equal x. As soon some of us, we see fractions, we start shaking, we get nervous, stress comes to us. No, you are in a pre-calculus class. Don't do those stuff, correct? I'll show you how to deal with fractions. Some of us, we try to add these two with a fraction, then it gets too much and say, wow, what to do? Now, when you are dealing with fraction, the easy way, find the LCM between the denominators. What is the LCM between 4 and 5? I was not your teacher in elementary algebra. I would show you the easiest way. LCM between what? 4 and 5. LCM between 4 and 5 is 20. Correct? After you found your LCM, multiply your LCM to all terms. It means multiply it here 20, multiply here 20, and multiply this side also with 20. Correct? You multiply here with 20, you multiply here with 20. When I say this to students, they immediately multiply and they keep the denominator. No, the purpose of multiplying is to get rid of the denominator, to get rid of the fraction. Correct? Look how I will deal. 4 goes 5 times to 20. I can cancel it out. 4 goes 5 times to 20. I'll keep it like this. Write the answer. You have 5 parentheses x minus 1 minus 5 goes 4 times to 20. It means your second is negative 4 times 2x plus 3. less than equal 20 times x gives you 20x. Now here distribute, be careful with the sign, and after that combine like terms, and it becomes a very simple inequality. 5 times x gives you 5x. 5 times negative 1 gives you negative 5. Negative 4 times 2x gives you negative 8x. And negative 4 times 3 gives you negative 12. Less than equal 20x. Combine like terms, these two and these two. 5x minus 8x gives you negative 3x. Negative 5, negative 12 gives you negative 17. Less than equal 20x. Now bring the x's to one side and number to the other side. It means add 17 to both sides. Or some people, they just bring x to this side. I recommend you to do this because I told you to keep your variable on the left because you don't have a lot of practice. You easily can do a mistake in the answer. Then do it this way. Negative 3x, negative 20x gives you negative 23x. These two cancels out, less than equal 17. Now divide both sides by negative 23. These two cancels out. X, I know I'm a good student. I divide by a negative number. I'll flip the symbol of inequality, and my answer is negative 17 over 23. Next step, how to show it on the number line and write your answer in notation form. Mark somewhere as a negative 17 over 23. X greater than this number. Then bracket open to the right to where? To infinity. Final answer, bracket negative 17 over 23, comma, infinity, parentheses. Next topic in your book is compound inequalities. They want to discuss with you compound inequalities, correct? What is a compound inequality? A compound inequality, usually we use the inequality sign on two sides of a sentence, or we give you two inequalities or two or more than two inequalities at the same time. Correct? Let me put a topic here for you. The topic is solving a compound inequality. For example, if they give me a compound inequality, let me write a good one for you, then example number one, because in your book, immediately they start with the fraction one. 2x plus 1 less than 11 greater equal to, let's say, 13. Not negative 13. Correct? How to solve this inequality? First of all, as you see on two sides of your variable, which your variable is in the middle, you have the inequality sign. To be honest, actually this is two inequalities, two separate inequalities, but we write it this way. If I separate them, you have this one, 2x plus 1 less than 11, and 2x plus 1 greater equal negative 13. Some professors, they want to teach you this way. Separate them, then solve them, then draw both of them in a one number line, and after that write your answer in notation form. I like it, but what is the problem? Sometimes when you copy the second inequality, some students, they forget to read their inequality from the variable side. You see, when I'm writing the first one, I'm reading from left to right. 2x plus 1 less than 11. When I'm writing the second one, 2x plus 1 greater equal negative 3, I'm writing from the variable side, from right. That's why they get confused. They put the sign again like this here, and they easily do a mistake. Then what is the best way that I like to solve? Keep it like this. Keep your inequality like this. 2x plus 1 less than 11 greater equal negative 13. Whatever operation that you are doing in the center or in the middle, do that operation on both sides at the same time. How? Look, I will first subtract 1 from the middle, I'll subtract 1 from the right, and I'll subtract 1 at the same time from the left. Correct? These two cancels out. 2x less than 11 minus 1 gives you 10. Greater equal negative 13 negative 1 gives you negative 14. Now, next step, I will divide the middle by 2, the right side by 2, and the left side by 2. Correct? I'll end up with x less than 5 greater equal negative 7. Now, draw your number line. Focus here. Draw your number line. Mark both numbers on your number line. Focus. Do not do this. Negative 7. Okay, the professor just say marked. That's wrong. You're dealing with the number line, right? We have to focus on the order. Which number is bigger? That one goes to the right. Here 5. Here negative 7. I shouldn't explain these to you. And I'm thinking I'm explaining too much. I shouldn't. You already know. You get tired of all these explanations. But still, I'm explaining. Now, read the first part. X less than 5. For less than, you are using a parenthesis and you are going to the left. All the way to where? To negative infinity. Now, read the second inequality, this part. But please read it from variable side. Read it this way. X greater equal negative 7. For greater equal, you use a bracket. Of course, greater is your right side. To where? To positive infinity. Now, where is your final answer? Where is X? X is the area that both lines overlap. It means here, let me shade it with blue. Look, this is your answer, not all of them. The rest is useless. You don't need those. This is your X from here to here. The area that both graphs are overlapping. Now, how to write your final answer? Just copy this. That's your final answer in notation form. Bracket, negative 7, comma, 5, parentheses. Really easy. It looks crazy, but it's really easy. Correct? One more example of this compound inequalities. Then I'll stop the lecture here because I think this is the last topic. No, we have one more topic, absolute value. And that's it. That's all about 2.3. Let's do another example first. 3 minus x over negative 4. 3 minus x over negative 4 less than 1/2 greater than negative 1/2. Your step 1 is to get rid of the denominator. What is the LCM between 2, negative 4 and 2? Of course, it's negative 4, correct? Or 4, your LCM, maybe you are not aware of that negative. Your LCM will be 4. You can multiply all sides with 4, but because you have a negative in the denominator, it's okay if you multiply it with negative 4, but be careful with your rules or properties. I will multiply here with negative 4. I will multiply here negative 4, and I will multiply here negative 4. Start simplifying. 2 goes 2 times 2, 4. Negative 2 times negative 1 gives you 2. You see, even I do 2 steps together. Because I multiplied my inequality with negative number, I'll flip the sign. Negative 4 cancels out with negative 4. I have here 3 minus x. Again, 2 goes 2 times to negative 4. 1 times negative 2 gives you negative 2. But flip the sign, please. You see? Now it's the same thing that you had in the first example. Subtract 3 from all sides. These 2 cancels out. Be careful with the sign. Again, I'm telling you, you are in pre-calculus. If you write x, don't expect that I'll give you a full mark. It's totally wrong, right? Your answer will be totally wrong. Focus on the signs. Negative x greater than negative 5 less than negative 1. Of course, you are not looking for the negative x, right? You are looking for the positive x. Then again multiply all sides with negative 1. Negative 1 times negative 1, 1. I multiplied with the negative number. I'll flip my sign. Here, negative x times negative 1 gives you x. Flip the sign. Negative 5 times negative 1 gives you 5. Number line. 1, 5. Read the first one. X less than 5. Parentheses, moving to the left to infinity. X greater than 1. Greater than 1. Parentheses, moving to the right to positive, to here negative infinity, here to positive infinity. Shade the overlap area. That's your answer. Then parentheses, 1, 5 parentheses. Correct? I'll stop the lecture. I'll make a separate video on absolute value inequalities because I want to discuss it in 2 different methods. What is intersection means, what's a union means. I'll stop the lecture here because it will be too much for you to have all of them, and I'll do another video on part 2. Until that, see you in part 2 of 2.3.